All right, so we're back and we're going to work on a video of finding the upper and lower sums of a region today. Before we get started, we'd like to thank our corporate sponsors, the Crafty Badger and Sticky Feet Reptiles at stickyfeetreptiles.com. So the problem we're going to look at today is they want us to use left and right endpoints in the given number of rectangles to find two approximations of the area between the graph of the function and the x-axis. The function they gave us was 8 minus 2x. And they want it over an interval from 0 to 3, and they want 6 rectangles, right? 6 rectangles. So what I've done is I've went ahead and graphed these already. So I graphed them using Desmos. So we'd like to thank our good friends at desmos.com for the ability to do this. So you'll look, this is the graph of 8 minus 2x from only 0 to 3. Right, I put my left-hand rectangles in first, as you can see, right? And because there's 6 rectangles from 0 to 3, each of these rectangles has a base of a half, right? So I go 0 up by a half all the way up to 3, my left-handed rectangles. In order to find the actual area of this using my left-hand rectangles, right? Let me make this a little bit bigger here so we can see. So we all know that the area of a rectangle, right, it is base times height. So the base of these is all going to be a half because of our number of rectangles. So I'm going to put 1/2 times, and then I'm going to list all of the heights, right? The height of the first rectangle, as you can see, that function at 0 is 8. So my first rectangle is 8. The second rectangle down here has a height of 7. The third rectangle, if I keep going, 6, 5, 4, and 3. Right, so if I take and distribute this through, I would get the base times height for all 6 of those triangles. So let's see what we get here. So I have 6 and 4 is 10, 7 and 3 is 10, so that's 20, 28, looks like 33, and then half of 33 would be 16.5. So it looks like my area using the left, or in this case the upper end sums, would be 16.5. Now I can do the same thing with my right side, right? So let me switch my rectangles over here. Instead of left endpoint, let's do the right endpoint. And if I use my right endpoint, it looks like this. You'll notice all my rectangles start on the right side at the function. So my values look something like this. So the height of my rectangles will be 7, 6, 5, 4, 3, and then finally 2. So all the rectangles are the same, except I'm taking this first one off and adding a new one on to the end. So I'm going to do the same thing here. For the right side, I'm going to take 1/2 because that's the base of all my rectangles. First one, and I'm going to keep going. Second rectangle, third rectangle, fourth rectangle, fifth rectangle, and sixth rectangle. So if I add these together, I get 10, and 10 is 20, and then 20 plus 7 is 27. So this is 27, and then half of 27 is 13.5. So my area under the curve, based on my lower and upper limits here, looks to be between 13.5 and 16.5. So if you actually found the integral from 0 to 3, you would find that area under the curve to be between 13.5 and 16.5. We will be doing a video on definite integrals in the future, so make sure you stay tuned, like and subscribe, and we appreciate you watching.